All right, we have skinned our character, and now we are ready to start creating the controls for our rig. So I'm going to walk through the process manually, and then I'm going to show you the tool I made that can be very helpful. So we're going to be making NURBS curves as our controls. So that's under the curved surfaces menu. Going to create a control. And then in order to place a control properly, so I could hypothetically just like hold down the V key and like snap my control here and kind of like size it and do any kind of rotation so that it is aligned with the joint properly, like so. And okay, great. Keeping in mind that all of these things are adding values in my channel box, and just in the exact same reason why we don't want any of our joints to have rotation values in them, we don't want our controls to have values in them, because we cannot easily zero them out. So if I zero this out, it goes all the way down back down to the floor. So this can be a major problem. So instead of moving the control itself, I always want to place the control in a group. I do this by hitting Command G, and now we have a group. So I'm going to name my group. So we're going to start with the center of gravity control. So I'll go control curve, center of gravity. I'll name, and then I'll put a little P. So this is a parent group, control curve, center of gravity, and this is the control curve from the center of gravity. So this is the group, and this is a control. I use the parent group to move and place the control, because if I move the parent, the child does not have values put into its transform. Okay, so we want to use the parent group. Now, it is a big pain in the butt to get your controls aligned properly. So there's a shortcut that you can use, which is using a parent constraint to take our control from the floor and place it and orient it exactly how we want it to be, which is in line with the joint. So I'm going to use a parent constraint to place my control. So I'm going to select the center of gravity, because that's going to be the joint that's just telling our control group where to go. So select the center of gravity, then select my group, because the joint is the boss of the group. So joint first, then group. Constraint. I'm going to use a parent constraint with maintain offset turned off. If this is off, the constraint will snap the group to the joint. So if I say add, it has moved and rotated my control. The constraint has now done its job, so I can delete the constraint. I'm going to take just a minute to rotate my control so it is a little easier to grab. It has a value in it now, so I'm going to make sure to freeze the transformations after I did that. And now we have this control that is placed and aligned properly with my joint. So that was a little bit of a pain in the butt. We had to make a constraint, we had to do this other stuff. I made a tool that can do all of this for us. You can find it on my GitHub, which is jcontour, and it is the Maya make rig control. I have it linked. It is pinned to the front of my GitHub. So Maya make rig control. Basically, this script creates and positions a control curve at the location of a selected joint. So if I click on the create CC Python script and then go to the raw file, this is a script. I'm going to hit Command A to select everything, Command C, go back to Maya, open up the script editor, and actually I already have it open, but let's pretend I don't. I'm going to open up a new Python window, paste my script in. I'm going to then file, save this script to my shelf, and I'm going to call this make control. click OK. I already have it saved, so I'm not going to do it, but type in the name and click OK. And it will show up on your custom shelf. So the way that this tool works is you click the tool to open up the window, select the joint that you want to make a control for, make the control, and it gives you the option to do a little bit of rotation if you want. And then that's it. So now you close it. I might do a little bit of extra scaling. Make sure that you're scaling the group and not the control. And there we go. Next up is the spine. So open up the window, make sure the spine is selected, make the control, rotate it, and then do any scaling that you need to do. Great. Close this, open it, make a control, rotate that, and do any scaling you need to do. Alrighty. Keeping moving, close, open, make your control. I like my head control to be this direction. And I'm going to scale this down a little bit and kind of stretch it out. So this is my head control. All right. Okay. I'm going to be making an FK spine and IK arms and legs. So the FK spine, once we have all of the controls created, which we do, we can go ahead and make Orient constraints to control all the way up the spine. So an FK spine is a rotation-based rig. So the control is controlling the rotation of the joint. I'm going to start with the spine because the center of gravity is a little bit special. So I'll start here. The control is the boss. So control first, then joint. Make a constraint, Orient constraint. If we look at the options, I have maintain offset turned off. So first control, then the joint, constraint, Orient constraint. First the control, then the joint, Orient constraint. Control, joint, Orient constraint. It can be really challenging to remember the order that you select things when you're making constraints and also working with parenting and all of that. So a little trick that I've learned is that to think about first this, then that. So for parenting, this is a child of that. So first select this, then select that. For constraining, this is the boss of that. So first select this, then select that. So first this, then that. This is the child of this. This is the boss of that. All right, so after we make our Orient constraints going up the spine, we test them. That looks like it's working. Good. 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 Now, in order to make everything move as a unit, we want to parent up our spine hierarchy. So we want a hierarchy of controls that matches the hierarchy of joints. So right now, the head is a child of the neck. So we take the head group and make it a child of the neck control. So we want to make sure to keep the group in the hierarchy. Our hierarchy should go group, control, group, control, group, control. The neck is a child of the chest. The chest is a child of the spine. And the spine is a child of the center of gravity. Okay, let's do that last constraint. The center of gravity is special because it uses a parent constraint instead of a Orient constraint. This is so that we can make our character kind of move up and down. So it's controlling the position as well as the rotation of the center of gravity joint. So I'm just going to click this maintain offset box, turn that off, and click add. So just double checking, I can move it and I can rotate it. If I grab all my joints, all my controls, I can test, and that was pretty good. Okay, so let's do the legs next. So an IK control rig sets up the leg position, which is driven by the position of the foot. So it's driving it from the bottom up. So if I lift my foot, my knee comes up, and then my hip rotates accordingly. So let's create a control for the foot and a control for the knee. So make a control. There we go. I'm going to do a little bit of scaling here. Good. Let's make our knee. Make a control. I'm going to scale this down. And the knee control needs to move out directly in front of the knee. And one thing that's kind of fun is that the rotation of the knee control doesn't really matter because it works differently than an Orient constraint. So I like to rotate it so the control is directly up and down. And I will scale it down just a little bit. Okay, so the knee control directly out in front of the knee. The last one is the foot control. So I'll make the control and rotate it here and scale it down so that it fits our foot. Okay. All right. Great. Let's do the same on the other side. Scale it down. Make a new control for the foot. Scale it down. We'll make another one for the knee. Okay. All right, so we have 2 ankles, 2 feet, and 2 knee controllers. We're also going to create a control for the Hula joint. So there's that Hula joint. Make a control. And I'm going to scale this a little bit so that we can distinguish it from the center of gravity. All right. Okay. Here we go. So to make an IK rig, one of the biggest things is that we create an IK chain from the hip to the ankle. So the IK chain is, the IK tool is accessed here. And you want to make sure that in your tool settings that it's set to rotate plane. So very, very necessary. You know that you're in rotate plane because after you create the tool, you'll see a big white arrow pointing out in the direction of the knee. So once you have the tool activated and you've confirmed that it's rotate plane, you can go in and click once on the hip and once on the ankle, and you get a IK chain. Here's that arrow I was talking about. Hit enter, and we'll do another one for the other side. Click once on the hip, click once on the ankle. We have our chain. Okay. I'm going to name this IK left leg, IK right leg. So we have 2 IK handles, and we need to hook them up properly. So the way that we connect up our IK rig is first we start off with the foot control. So the foot control starts with controlling the orientation of the foot joint. So I'll make a orient constraint here. And then it also controls the position of the IK handle. So I'm going to make a point constraint to the IK handle. With those two things combined, I can rotate my foot and move my leg. So that is, again, the ankle control controls the orientation of the ankle joint and the position of the IK handle. Make sure to test it after you do it. Great. The next step for hooking up an IK rig is to connect in the knee control, which is controlling the pole vector of the IK handle. So we're going to make a pole vector constraint here. And what this does is we'll aim the knee at the control. So that's, again, knee to the IK, pole vector constraint. To finish hooking up the feet, we have our ball of the foot control, which is controlling the orientation of the ball joint. Same on the other side. And so with these controls, we can rotate our feet like this. And to hook up the hips, we're going to do an orient constraint to the Hula joint. So from the Hula control to the Hula joint, do an orient constraint. And then we want to make sure to parent up our controls properly. So the ankle and the foot controls are going to be children of the ankle joints. So the foot group is a child of the ankle group. Do that on the other side too. Ankle. Foot group, a child of the ankle control. The knees just stay out by themselves, but the Hula joint is going to be a child of the center of gravity control. So here, and this is so that when I move my center of gravity, the Hula joint will follow and give us the ability to do little shimmies. So a little hula. All right, so that's the legs. We're going to do the same thing to hook up the arms. So I'm going to start with making controls for my arms, my wrists. Scale it down. Also my elbows. Down. Let's do the other wrist. And the other elbow. I'm going to move both elbows back at the same time so they're in the same spot. All the controls have been made, so we're going to make our IK handles. So we click once on the shoulder and once on the wrist. Our IK handle. Go again on the other side. Once on the shoulder, once on the wrist. Going to name these IK left arm, IK right arm. And then we're going to do those same exact constraints that we did for the legs. So the wrist control starts off by controlling the orientation of the wrist joint, and then it controls the position of the IK handle. Point constraint. The elbow control controls the pole vector of the IK handle. So, quick test. Make sure this works. Make sure that works. Looks good. And I can very easily zero things out. So, other side, wrist control orient constraint on the wrist joint, and wrist control point constraint on the IK handle, elbow control, pole vector constraint to the IK handle. And this is our rig. All the controls have been made.